All right, well, good morning, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. How's everybody doing? Good, Mr. Q. All right, good. So warm-up number 44 is on your screen, and it reads as follows. Number one, compute the sum, difference, and product of, they give us two binomials, one of them, parentheses, 5x minus 1, close parentheses. Then it has a little symbol with an arrow up, which means and. Parentheses, 3x plus 1, close parentheses. So you need to find the sum, difference, and product of those three. We've been practicing these already for the past 2 weeks. So hopefully it's an easy problem for you guys. Number two says solve and allow for imaginary numbers. And they give us a quadratic equation that reads x squared plus 18 equals y. Now we know 5 different methods of solving this. Use any method that you think. Number 3, it says graph f of x equals x squared without a table. By now, those parent functions should be automatic. Then it says, then write the rule for the transformation if the given rule is g of x equals a times f of parentheses 1 over bx minus h close parentheses plus k. And the parameters given are a equals 1, b equals 1, h equals 5, and k equals -7. Then it says then transform graph the transform function. And number 4, it says solve by completing the square. X squared minus 4x minus 6 equals 2y. Copy that and go, and then I'll come right after and work those out with you. Go. All right, so let's go over the warm-up. For the sake of time, I'm going to go over all of these to make sure we got these. Number 1 says compute the sum, difference, and product of 5x minus 1 and 3x plus 2. To save space, I'm just going to do here, I'm going to put a plus here for the sum. So I need to combine like terms since there is no coefficient outside of each. So 5x plus 3x, that's 8x. And then -1 plus 1, they cancel. So our sum is 8x. Difference. I'm going to write 5x minus 1 minus 3x plus 1. What is the most important thing to remember about this one? That we need to distribute this negative to both terms in here. That gives us -3x minus 1. And we bring this down. Combine like terms. What is 5x minus 3x? That's 2x. What is -1 and -1? That's -2. That's our difference. Last but not least, product. I'm going to write it up here. We got 5x minus 1 times 3x plus 1. All right, here it goes. Distributive property. 5x times 3x, that's 15x squared. 5x times 1, that's 5x. Then the second term, -1 times 3x, -3x. And -1 times 1, that's -1. Can we combine like terms there? Yes, Mr. Q. What is 5x minus 3x? That's 2x, and it's a positive. Bring down the 15x squared. Bring down the -1, and this is our product. Now, we don't go any further on this one because we don't have I squared, we have x squared. So we'll stop right there. Let's go to number 2. For number 2, it says solve and allow for imaginary numbers. So this one, what method would you guys like to use to solve that one? Alberto.
For number 3?
Number 2, what method? There's 5 different methods. Okay, good. I'm going to use square roots. So x squared plus 18 equals 0. I'm going to solve by square root. So therefore, this is, we get rid of the 18. So we subtract 18, subtract 18. We end up with x squared equals to -18. And lastly, we take the square root. So this is, and by the way, yesterday's home play or the weekend home play, you needed to change this. Is that correct? So let me rewrite this over here. I'm going to do the work over here. Square root of negative 18 is the same as square root of negative 1 times square root of 9 times square root of 2. Okay, so what is square root of 9? 3. What is square root of negative 1? That's I, and then I just bring down the square root of 2. And that's my solution. What kind of number is that? Well, it's got an I, that means it's an imaginary number. Okay, let's move on. Let's go to number 4. Number 4, I'm gonna do number 3 at the end, so like that I have plenty of space for that. So let me create some space here for number 4. And the reason I'm revisiting this, because we're gonna come back to it, guys, and completing the square is a skill that it's a must, you need, okay? First things first, step 1, it needs to be in standard form, equal to 0. Highest to lowest degree, yes. However, it's not equal to 0, so I write it equal to 0. Step 2, divide by the leading coefficient. What's my leading coefficient? 1, so I end up with x squared minus 4x minus 6 equal to 0. Step 3, eliminate the constant. What's my constant? The negative 6, so I add 6, I end up with x squared minus 4x, empty space, equal to 6. I complete the square here. How do I complete the square on this side? Well, I take the coefficient of x and I add that divided by 2 squared. And what do I do to one side? I do to the other side. Let's simplify this. X squared minus 4x plus 4 equals 6 plus 4. What is 6 plus 4? 10. X squared minus 4x plus 4. Sorry about that noise, guys. It's because I'm outside and right now the jets are going by. All right, so at this point, we need to factor. We need to factor this trinomial. Does everybody remember the shortcut? Yes, Mr. Q. Yeah, square root of the first, square root of the last, sine of the middle, squared equals to 10. And lastly, we do the square root to each side to cancel that square. So we got x minus 2 equals plus minus square root of 10. Solve for x, so I add 2, x equals 2 plus minus square root of 10. And we write our two equations. X sub 1 is 2 plus square root of 10. And x sub 2 is 2 minus square root of 10. And these are my solutions. X-intercepts, roots, zeros. Is it coming back? Yes, Mr. Q, these are my favorite. All right, good. Oh, my bad. We're in high school now. You guys don't talk like that. Yes, Mr. Q, these are my favorite. You guys remember in 8th grade, some of you, that your voice was changing and all of a sudden you hit those high notes, yeah? All right, let's go to number 3. Let's see how we did with number 3. See if you guys remember that one. Here it goes. Number 3, let me make some space here. All right, so number 3 reads, graph f of x equals x squared without a table. So I remember when we covered these that I said, when you get to these guys, second nature or something that you need to remember is how to graph them like automatic. So we're getting there. So you guys need to know that by now. So here goes without a table. Let's see if you remember. I have an x and I have f of x. To graph anything, I said, what domain do we use? Oh, we use -2, -1, 0, 1, and 2. All right, so what does that mean? That I take that x value and do whatever the function is asking me to do. What is the parent function? Squared. So what is -2 times -2? -2 times -2 is 4, Mr. Q. Okay, so that goes right there. What is -1 squared? -1 times -1 is 1, which is right there. And then 1 squared, 0, 0. 1 squared is 1, 2 squared is 4. So my parent function is right there. Right, Juan? These have to be automatic by the time they get to pre-cal and cal, yeah? Yeah, so now that we have that, guys, now they're asking us to write a rule for the transformation given. So check this out. They give us a general rule, g of x equals a times f of 1 over bx minus h plus k. Let's label whatever parameters they give us. A is 1, b is 1, h is 5, and k is negative 7. Man, that's loud. It's because they're flying really low. Maybe they want to learn some algebra too. Let's go. All right, here we go. So I'm going to write my general rule now with all the parameters. Here it goes. G of x equals 1 times f of, parentheses, 1 over 1, x minus 5. And by the way, what parent function is it? A square, so that this needed a square there and a square there, and minus 7. The square right outside the parentheses. Okay, but since it's a transformation, now I'm going to rewrite it without the f for the function, because we know it's a function of g of x is a function of x. So here we go. So we write g of x equals 1 times, do we need to write that 1? No. Do we need to write the f? No. So we are at the parentheses. What is 1 over 1? 1. So do we need to write that? No. So I just write x minus 5 squared minus 7. That's our function that we need to graph. So what does that mean? That we have an h and we have a k. The h goes 5 steps to the right. The k goes 7 steps down. So whenever I am working with this to go a little bit faster, look up guys, I usually use this point right here, 0, 0. You guys see 0, 0 where it's at? Right here? I'm gonna take that point and move it according to the transformation given. So they tell us 5 to the right, 7 down. So I'm gonna go 1, 2, 3, 4, 5, 7 down, 1, 2, 3, 4, 5, 6, 7. So this point, 0, 0, now is right here, and it became 5, negative 7. And then if we transfer all the points down here, so that's what our graph should look like. Is it coming back? Yes? Yes, Mr. Q, because we are to move all the other points 5 and 7, 5 and 7, 5 and 7, and so on and so forth. Something like that. All right, let's move on. We good? Yes, Mr. Q, we love these. All right, good. All right. Our warm-up for today, agenda for today, warm-up number 44. We just finished it. We're working on complex numbers today. We're moving on, guys. You're like, what? Yeah, we already did plenty of practice. I got you guys warmed up to there. And today's going to be a good day. And you're going to be like, man, this is so cool. I know, right? And your home plate for tonight is pages 133 and 134. 133 and 134. All right. Asynchronous code for tonight, we got 4YRDQ. 4YRDQ. Asynchronous code 4YRDQ. So once again, if you miss anything on the notes, make sure you go to the chat, to the presentation on your synchronous time, and it should be in there, okay? All right. Your previous home play from the weekend, some of you, it was pages 121 and 124. You can submit that on Canvas. Just for the sake of time, I'm going to move on, and you have plenty of time. I give you guys till 11:59, which is till the end of this period. And then you can do that on your own. Some of you already submitted, which is good. And your home plate for tonight, once again, pages 133 and 134. All right? All right, here we go. Our objective for today, I can define and compute complex numbers. I can define and compute complex numbers. Oh yeah, we're moving on, guys. We're moving on up. All right, so define, basically I'm gonna do the definition one more time. Even though I already covered this at the beginning of the school year, I'm gonna revisit. We're gonna compute. We've been doing that on the warm-ups, haven't we? Computing. We're doing addition, subtraction, multiplication, and division. That's what compute means. All right, but what are complex numbers? Let's define that in our Freire model. Here we go. Complex numbers. Complex numbers are, definition, numbers that contain one real number and one imaginary number. Complex numbers are numbers that contain one real number and one imaginary number. Complex numbers are numbers that contain one real number and one imaginary number. Examples, 5 plus 3i, 12 minus 6i, 2i, and square root of negative 8. Non-examples, 23. Then we got x squared plus 3x plus 2, and negative 3 plus x equals 10. Copy that, I'll give you some time, and then I'll go over it. Ready? Go. There, yeah. All right. All right, let's see what we got, guys. Here it goes. According to the definition, stay focused, please. Here it goes. According to the definition says that complex numbers are numbers that contain one real number, underline that in red, and one imaginary number. One real number and one imaginary number. Okay, so let's look at the first example. The obvious one that I see is 3i, so I'm going to circle that in green, including that little plus. 3i, so we can say that that's our imaginary, which means that obviously the 5 is our what? Our real number. You're like, man, Mr. Q, this is so easy. I know, right? I got you. Let's go over this one. 12 minus 6i, we can circle the negative 6i. We know that that's our what? Imaginary, which means that positive 12 is our what? Our real number. That's why this is a complex. It's got both. But some of you are like, oh, snap, Mr. Q. How about this one? Okay, that's our imaginary, which means if we don't see the real, what is our real number? Think about it. Don't say it out loud. What would be our real number if it doesn't have anything there? What do you think, Mia?
1.
Close. Because if we put 1, then it would be part of the imaginary because it's multiplication. So
0.
0. So we put plus 0. 0 is my real number. Okay. So let's go with this one. This one, we know it's an imaginary because we can rewrite it as square root of negative 1 times square root of 4 times square root of 2. So what is square root of 4? Square root of 4 is 2. What is square root of negative 1? I, and then we bring down the square root of 2. You did that on the home plate, yeah? So if this is my imaginary, what is my real number? Mia?
0.
Yeah, let's go. Okay, so now that we have that, now it's obvious why these, look at them, why these, first the first two, let's look at the first two. These are not complex numbers because why? Jaziel, these are not complex numbers.
No imaginary numbers?
No imaginary number, okay. This one, also no imaginary, but also because it's a what? Who's got
Equation.
it? It's an equation, so therefore numbers are only expressions. So we're going to be working with expressions for right now with complex numbers. So let's hashtag this, hashtag. Okay, what you got? Hashtag what, Addie?
Hashtag no equations.
No equations. Hashtag what, Daniel? Danny, you there?
Oh, me?
Yeah.
Hashtag one real number, one imaginary number.
One real, one imaginary. Okay. That pretty much covers it, no? Yeah? Or we can do hashtag BAM. Oh, yeah.
Mr. Q.
Yeah.
Dominic is trying to get in because he wasn't able to get in earlier. But it's blocked, right? Do I tell him like
Hold
Just-
on, let me unlock it and yeah, tell him to try and come in again and I'll let him in.
Okay, thank you, Mr. Q.
So now that we have our hashtags, let's move on. All right, copy this one just to clarify. It says identify the real number and the imaginary number. So you're going to write 7 plus 3i. Copy the instructions at least for that one, so you can have it at least for this one. And it's going to go pretty fast. So everybody, bear with me.
Thank
With me.
you, Mr. Q.
Yep.
Thank you for unlocking the
Yeah, you're welcome.
meeting.
Yeah.
It's because I have like a lot of people on my internet. My mom working, everybody.
Okay. All right. Well, you're being recorded and you're going to be on the YouTube channel saying thank you, Mr. Q. I appreciate it, Dominique. All right, here we go. Identify the real number and imaginary number. So check this out. This is what I'm going to do. Down here, I'm going to write 2 lines down and then the letter R. That is a symbol for real number. And a little I is for imaginary. So the real number. What's our real number, Alberto?
What's the question?
What's the real number?
The bottom one. No, the top one. The R. And in the question, it's
In
7.
the expression, it's 7. Okay, yeah. How about the imaginary, Michael?
Right.
3i. Thank you. For the next one, guys, I just wanted to write it down here so you guys can see it. But for the next one, to save time, you can do this. Label it like so and like so. Okay, here we go, just to save time. Example 1Q, copy this. 5 minus 2i. And identify the real number and the imaginary number. All right. Alyssa, real number.
5.
5. So we label this one real, which means negative 2i is my imaginary. Hands if you got that. Okay, good. Let's move on. It's going to go pretty quick. Copy this one. Example 1 super Q reads negative 5i. All right. Hayden, real number.
Is it 0?
0. Okay. So I write that as so, which means that our imaginary is negative 5i. We good? Yeah? All right, show me your fingers, I'll come to your as to what we're looking at with complex numbers. Yeah, 5s. We know exactly what we're looking at, real number and an imaginary. Okay, let's do some practice on the computation first before we move on to doing the next portion. Example 2 reads, find the sum, difference, and product of 2x plus 5. Remember, this symbol means and 3x minus, x minus 3. Once again, 2x plus 5 and x minus 3. For the sum, I want you to use blue. So I'm going to put a little plus, and we're going to write 2x plus 5 plus x minus 3. For the difference, we're going to do a subtraction here, and we're going to do that in red. 2x plus 5 minus x minus 3. And for the product, I'm going to put a big dot for multiplication, and we're going to do that in green. 2x plus 5 times x minus 3. All right, let's do this one together. Should be automatic by now. We've been doing these on the warm-ups. Yes. Here we go. For the sum or addition, we have 2x plus 5, parentheses, plus parentheses x minus 3. Since there is no number outside the parentheses multiplying, we don't really care about the parentheses. We're just combining like terms. What is 2x plus 1x? That's 3x. Next, we got positive 5 and negative 3. Combine those, that gives us positive 2. This is our sum. Next. For subtraction, we got 2x plus 5 in parentheses, then minus parentheses x minus 3. What is the most important part of this one, guys? To distribute the negative into the second parentheses. Don't forget that. So this is negative x plus 3. Bring down the 2x plus 5, and now we can combine. What is 2x minus 1x? That's 1x. And what is 5 plus 3? That's 8. That's our difference. All right, let's go to multiplication. For multiplication, we distribute the first term to the second binomial and then the second term to the second binomial. So here we go. 2x times x, we got 2x squared. 2x times negative 3, negative 6x. Now we got 5 times x, that's positive 5x. And 5 times negative 3, that's negative 15. At that point, we look at it and say, can we combine like terms? Yes, negative 6x plus 5x, that gives us negative 1x. Bring down the 2x squared and bring down the negative 15. Are we done at that point? Yes, because this is not I squared, it's just a regular x squared. Show me your fingers, how come you are with these? 5, 5, 5, 4, 5, 4, okay. All right, so I showed you how to do this one. Let me give you another one for you to practice by yourself. Here it goes. Example 2q. Same thing, find the sum difference in product. 7y minus 2 in parentheses and 5y plus 4 in parentheses. Copy that and go. I'll give you some time and then I'll come right after to do that with you. Go. All right, let's see what we got. For the sake of time, I'm gonna go over this one. We got addition, there's no coefficient outside the parentheses, so I just combine. What is 7y plus 5y? That's 12y. What is negative 2 plus 4? That's positive 2. Hands, have you got that? Okay, good. Thank you. For subtraction, what is the most important part here is to distribute the negative to the second binomial. So this becomes negative 5y minus 4. Negative 5y minus 4. Bring down the 7y minus 2. We combine like terms. Let's see. What is 7y minus 5y, that is 2y. And then we got negative 2 and negative 4, that's negative 6. Hands, have you got that? Okay, good. Multiplication, I'm going to distribute 7y times 5y, that's 35y squared. 7y times 4, that's positive 28y. Then the second term, negative 2 times 5y, that's negative 10y. Negative 2 times 4, that's negative 8. At that point, I can combine like terms, which is right here in the middle. 28y minus 10y, that's positive 18y. I bring down the 35y squared, and I bring down the negative 8. And I'm done. Hands if you got that for the product. Okay, good. Yeah. Okay. So far so good? Yeah? Let's do another one. Here it goes. Example 2 super Q. We got negative 3x plus 1 and negative 3x plus 1 and negative 5x plus 3. Find me the sum difference in product. Once again, I'll give you some time and I'll come right after to go over it with you. Ready, go. All right, let's see what we got. For the sum, what'd you get for the sum, Octavio? Sum.
Negative 8x plus 4.
Bam. Hands, have you got that? That is correct. Difference. What'd you get for the difference? Esmeralda.
2x minus 2.
2x minus 2. Hands, have you got that? That is correct, yes. For those of you that didn't get that, remember you need to distribute to both terms of the binomial to the right of that negative sign, okay? Product, what'd you get for the product? Let's see. Angie, what'd you get?
15x squared minus 14x plus 3.
Plus 3. Hands, have you got that? Let's see, 15, 9, Yeah, that is correct. Let's go. Just remember to distribute, and combine at the end. All right, so I think we got this. Just to make sure that our processes are there, I'm gonna give you one now for you to do, all three, but without any numbers. How about them apples? Yeah. Example 2 super Q, find me the sum difference in product of AX plus C and BX plus C. Let's see how you do. I'll give you a head start. Copy that and go. All right, here goes. I'm gonna go over these just to make sure we got it. Now, I wanted to give you these so that you can trust your processes, guys. I've been giving you plenty of practice. I'm kind of like, let's see. Oh yeah, I'm kind of like Yoda. I'm training you guys, yeah? Jedi mathematicians. So here we go. I'm gonna go one step at a time. On this one, there's no coefficient outside the parentheses for the sum, so I just combine like terms. I'm gonna start with AX and BX, so I'm just gonna write it as AX plus BX, okay. Can I combine C plus C? Yes, it's 2C. Does everybody see what I did there? You guys got that? Yeah, okay, all right. For subtraction, what is the most important part for subtraction, guys? That's why I'm giving you these kinds, so like that you can distribute that negative into the second binomial, negative bx minus c. I bring down ax plus c. All right, let's combine stuff, ax and negative bx. I'm just gonna write it as ax minus bx. And then we have c minus c, those cancel, so this is my difference. Okay, let's go to multiplication. Let's see. AX times BX. What is A times B? That's AB. What is X times X? X squared. Okay. What is AX times C? That is ACX. Notice that I wrote it in alphabetical order. AX times C is ACX. Okay. Next, C times BX. That becomes BCX in alphabetical order. C times BX is BCX. Okay. And what is C times C? C times C is C squared. Next step is to combine like terms. So let's see. Can we combine anything? No, everything's pretty much different, Ms. Q. Okay, so at that point, we're done. And once again, I wanted you to go over these so you can see the processes by themselves, not worrying about the numbers. Are we good with the processes? Yes? Yes, Mr. Q, we got this. All right, so let's be done with this simple stuff. Let's move on, yeah? Let's crank it up a notch. Let's go. Example 3, copy this. Find the sum difference in product of 5 plus 7i and negative 2 plus 9i. You're like, Mr. Q, haven't we been doing these? Of course. But believe it or not, let me give you a shocker. Here goes a shocker. Ready for the shocker? Believe it or not, there's some people that don't do their warm-up. Can you believe that? And they're like, no way. Oh, yes. I sense it. I sense it in the force. So let's do this one together. For the sum, I'm going to write 5 plus 7i plus negative 2 plus 9i. For difference, I'm going to write minus. We got 5 plus 7i, parentheses, minus, parentheses, negative 2 plus 9i. For the product, I'm going to write product, 5 plus 7i times negative 2 plus 9i. All right, let's see if we got our processes down. For addition, there's no coefficient outside the parentheses. We just combine. I'm going to start with the real numbers. What is 5 minus 2? Oh, that is 3. Okay. Imaginary. What is 7i plus 9i? That is 16i. Hands if you got that. Okay, good. Let's go to subtraction. What is the most important thing about subtraction? Once again, guys, you distribute that negative to the second binomial. So this is plus 2 minus 9i. Bring down 5 plus 7i. and then we combine like terms. Let me start with the real numbers first. What is 5 plus 2? That is 7. Imaginary. What is 7i minus 9i? That's negative 2i. That's our difference. And let's go to multiplication. I'm going to start with 5 times negative 2. That's negative 10. What is 5 times 9i? That's positive 45i. Next, 7i times negative 2. That's negative 14i. 7i times 9i. That's positive 63i squared. Can I combine stuff here? Yes, Mr. Q. 45i minus 14i. That is positive 31i. Bring down the negative 10, bring down the positive 63i squared. Are we done here? No. You're like, what? Yeah, remember here, make a little note here, put a little asterisk, a heart. Aw, just write substitute, and we write that I squared is equal to what? Negative 1. So that means here, we're going to substitute negative 1 for I squared, bring down the 63, bring down the positive 31i, and bring down the negative 10. All right, let's do that. What is 63 times negative 1? That's negative 63, 31i, negative 10. And then one more time, can we combine like terms? Yes, what is negative 10 and negative 63? That's negative 73 plus 31i. That is our product. Now, I hope this seems familiar because we've been doing these on the warm-up. Is that correct? Yes, Mr. Q. Show me your fingers. How come you are with these? 1 being the lowest, 5 being the highest. I see 5, 5, 5, 5, 5, 4. Okay, yeah, we got these. So let me give you one for you to do by yourself. Ready? Here we go. Example 3Q, negative 7 plus 3i and negative 3 plus 2i. Find me the sum, difference, and product of those. Ready, go. I'll come right after and do those to make sure we got them. All right, let's see what we got. For the sum, Alyssa, what'd you get for your sum?
I got negative 10 plus 5i.
Hands, have you got that? That is correct. Let's go. How about for the difference? What'd you get for the difference? Bianca, difference. Bianca, you there? Ivan, help her out. What'd you get for the difference?
I got 1 plus 1i.
1 plus 1i? Okay, so let's see. If we distribute the negative here, we got positive 3 and negative 2i. I bring down the
Oh, wait, no. Okay, yeah.
7
I accidentally copied down the same thing.
3. Okay, so what'd you get? Ivan.
Huh? Oh, yeah.
Roman, help him out. What'd you get?
I got negative 4 minus I.
Negative 4 minus I. It's close. Negative 4 is correct. However, we have 3i minus 2i should give us positive 1i. Careful on that one. Hands if you got that. All right. And last but not least, let me do this one. Distribute 21. Distribute negative 14i distribute negative 9i, distribute positive 6i squared. Combine like terms, yes, that's negative 23i, bring down the 21 and plus 6i squared. And here we said don't forget to substitute what? Negative 1 for I squared, bring down the 21, negative 23i, and plus 6 times negative 1. So what is 6 times negative 1? That's negative 6, bringing everything else down. Combine like terms. So what is 21 minus 6? That is 15. Bring down the negative 23i, and we're done. Hands if you got that. Yeah, let's go. So guys, so part of the home play is going to be this, what we just did with imaginary and complex numbers and labeling stuff. So that's done. What I want to go to next before we leave is I'm going to introduce you to where all these complex numbers and imaginary numbers are used. Because some of you don't see them because they are what? Imaginary. Hello. Hello. It's like ring, pick up. Let's see, Alberto. Can you pick up? Ring. We'll pick up. Unmute yourself. Say, what do you say? Ring.
Ring.
Hello. That's
Hello.
So I'm going to show you guys where we actually can see this at work. So here we go. Before I came into the classroom, guys, let me skip over these. I was a mobile electronics specialist. I think I already told you that. I know how to do sound systems in cars, alarms, and so on and so forth. So if I was to be using all those skills for bad, I think I can break into a car in 5 seconds. You're like, what? Oh yeah, I can deactivate the alarm. I can actually jimmy, which means open the lock without any time, like in 5-10 seconds. Oh yeah, I got those skills. So
hypothetically speaking, how?
Yeah. So with that said, when I was a kid, I was really, and I don't know if you guys noticed that with the instruction that I break down all the different terms that we use, because I want to make sure that you understand what everything comes from. When I was a kid, I used to learn like that. And that's why I remember I used to take apart the little radios. They used to give me little radios. I used to take off the screws and look at all the components. And I used to learn like that because I wanted to see where everything came from. So one of those days, I took different components. I took a little light bulb and a battery and some wire, and I put it on the little board. And then I put a little switch at the end, and I made a little lamp by myself, just by connecting a battery and a little light. So it looked like this. Here's a little light bulb right here, a battery, and then over here is a switch. So whenever you tap the switch down, the light bulb turns on. So imagine that I started a business and called it Q Electronics. Let's go. And all of you worked for me for free, right? All right, am I right? Yeah? And just are like, I don't think so, Mr. Q. So I had you guys put together this little components in baggies, and these are known as electric circuits. This is the basic one. Now it's called a circuit. Check this out. What does this look like? It looks like a little circle, doesn't it? Circle. But since it's in electronics, that's why it's known as a circuit. Okay? However, we need to include instructions, but me, to save money, I'm not going to print pictures because it takes money to print pictures. I'm just going to have you guys with a pencil draw a little diagram for this, and this is what it's going to look like. There's my diagram. This is known as an electric circuit. This is the basic electric circuit. Okay. All right. When you get to your asynchronous session, make sure you copy that diagram on your notes. Okay. So this is the basic one. Here's the battery. There's a plus and the minus on the battery. The plus goes to one side of the lamp and the minus goes to the other side. But in between, there's an interrupter called a switch. So like that, it only turns on whenever you press it down. Does that make sense? Yeah. So this is the basic electric circuit. Now let me show you more complex electric circuits. There you go. Now, Juan, does this look familiar? Yeah, right? You that tear apart all those computers, there you go. So guys, if you notice, there's little veins here of connectors. And what it does, it creates circuits. It goes in circles. and it connects to other things. Now, these are very complex. These here have other circuits within that circuit. So it's got so much power going on from one place to the other. But each component, look in here, you see these little rectangles and little cylinders? All these things have a name and they serve a purpose. Something like this. Now, some of the basic circuits have stuff sticking out like this, and today I'm going to talk about 3 of them that I want you guys to remember, and we're going to make sure that we got those, because on the next session, we're going to use complex numbers and put them to work, okay? So this is what I want you to copy. Copy this table down. 2 columns, one of them titled circuit component, and on the right side of that, make another column and title it symbol in circuit diagram. So the 3 components I'm going to talk about today is, the first one is known as a resistor. So the word itself, resistor, means that it resists amount of current or voltage going through. Now, to put it simple, and I'm not going to get into complex circuits or components, let's just think about, let's see, who's seen the old school light bulbs? You guys seen the old school light bulbs that it has like a very thin wire inside? Have you guys noticed that? Yeah? Some of you are like, no, Mr. Q, I was born with all LED. Okay. So anyways, the old light bulbs had a little wire in between, and whenever it had overpower, or it was too much power for it, that wire burned out. That is a good example of a resistor. So it looks like this. Here's a little wire. That's the symbol that we use in circuitry for resistor. Here goes another. The other one is known as inductor. The inductor, the purpose of that, check this out. If I was to get a pencil, or you can do this on your own at home. If you have a nail, you know, one of those to nail on wood, if you have a big nail and you have a wire like something like this that has plastic insulation, and you start winding the wire around the nail, when you put current to the wire, it takes longer to go through. It goes longer, it takes longer to go through. However, the experiment is that if you get that nail, you surround it with that wire, and you put a battery to it, it becomes a magnet. Yeah, some of you probably already did that by yourself. And the symbol for that, for inductor, is like this. Look, it looks like the wire, and it's like if it's winding in there. And what that does, it slows down the current as it's going through. The third component is a capacitor. A capacitor works as follows. It's kind of like a security guard in a circuitry. It allows the voltage to go through, but it doesn't let it go back the same direction it came from. Why? Because that avoids things from burning out, which some of you have experienced in the past because you were messing around with stuff. So that capacitor, look up, it lets it go through, but it doesn't let it come back. So it puts a stop to it. So look, it does this. Wants to come back? Nope, I stop it. No, I stop it. So the symbol comes from here. Stopping, look at my 2 hands. Stopping, look at this symbol. Looks like 2 hands going like this, right? So those are the 3 symbols and components that we're going to be talking about in these next sessions, and how we use that with complex numbers. Now, I'm going to give you the basic circuit, and we're going to label it. Ready? Here we go. Once again, we have resistor, inductor, and capacitor. Copy this, please. Example 4. Label the electronic circuit. Copy this diagram. It looks like a square. On the left side has like a little circle with a symbol. On the top, it has like a zigzag. On the right, it has like a twirly thingy. And at the bottom, it has the 2 parallel lines stopping it right there. And this is a basic diagram for a circuit. So here we go. I'm going to start with this one right here on the right side. What is that called now that you have it on your table?
Inductor?
Inductor, that is correct, inductor. All right. How about this one up here, guys? What is that one called?
Resistor.
Resistor, that is correct. And this bottom one down here in green, I'm gonna label it, the last one is the capacitor. And this one, guys, they use different labels. Right now, I'm just gonna use this one that it looks like an N turning. This is what they call voltage. Voltage. That means how much power is going in, okay? That's the basic circuit. So if I was to give you in your synchronous session to label another one, look up, a little bit more complex than that. Check this one out. Don't copy it because you're gonna do that on your asynchronous time. However, look at this one down here to the right, far right. What is this one, Josiel? What is this symbol?
The resistor.
Let's go. How about in here in the middle? What is this, Alberto? Alberto. What is this one?
Inductor.
Inductor. Oh my goodness, stay focused. And of course, these two on top right here, side by side almost, they're known as what, Mia?
Capacitor.
And so on and so forth, because I'm going to give you some more to do by yourself. There's this one that you're going to do also, and that one. So you're going to be labeling those. And I just want you to get used to what you're looking at in an electric circuit, okay? So with that said, your asynchronous code for tonight, once again, for YRDQ, okay? So once again, if you still are struggling with complex, I want to see you after lunch for tutoring, all right? Show me with the fingers how come to you are so far. With complex, 5, 5, 5s. Yes, we got this, all right? I'll stop the lesson right there, guys. Once again, tutoring after lunch, be there or be elsewhere. Peace, have a good one. Bye.